Okay, students, we are talking now on section 1.7. We will talk about quantities in physics. Now we'll talk about scalars and vectors. But before we'll talk about quantities in math. In math, we have just numbers and samples, and there are no physical meaning for these numbers or samples. But in physics, we have a meaning for each magnitude, and we have a units or directions for vectors. For scalars, we need to mention just the magnitude and the unit. It's just like the mass. If we say 5 kilograms, 10 kilograms, or the time like 3 seconds, 4 days, the distance, which is the distance between 2 points, the work in joule. For these quantities, we can't mention that the quantity or the measurement of the time is to the right or to the left or upward, downward, or something like that. This means it is a scalar. And the operations of for these quantities are simple. Just if we need to add 3 seconds to 4 seconds, it will be 7 seconds. If we need to multiply two numbers, two quantities, it will be easy. But in vectors, we need to mention the magnitude and the unit and the direction. For example, displacement, which is the shortest, which is the straight line between 2 points, we need to start from a point to a point, for example, from A to B. And we need to say the direction to the right, to the left, to the north. Velocity also is a vector. It is different than the speed. We will talk about them. We know them later. The acceleration, the force, the weight, all of them have direction. They are vectors. They have more complex operations. For example, if we add two vectors, for 1 plus 2 or 1 plus 1, it will not be 2. It may be 0 or it may be -1 or any value between them. We will see that in examples and in the class in the future. Now, for a vector A, each quantity in physics or in math, we need to name it. If we have a vector and if we name it as A, we need to write it and draw an arrow over it. This quantity is a vector. Also, we can write it or type it in bold fashion. In this way, it will be also a vector. We need to draw a vector in our problems. So how to represent a vector or draw a vector? The vector is a straight line. Its length indicates its magnitude, and it ends with an arrow indicates to its direction. For example, we have this vector A. Start from here to here. If we need to see its length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it is 14 units. If each dash is a unit. And the direction is to the right, downward. The vector minus A, it is also 14 units of length, but with opposite direction. This is the vector minus A. Look at this vector, which is B. It is 2, 4, 6, 7 units to the right, upward. The vector minus B, it is the same length, 7 units, but with opposite direction. Look at the vector A. It is its length and its magnitude is more than the vector B. Also, the direction for the vector A is different than the direction of vector B. The negative of the vector is just the opposite of that the vector by reflect that direction of the row. Look here for two vectors C and D. They direct upward to the y direction, but they are different in the length. So the vectors may be long or short. This way we can draw the vector. We need to know its direction and its length. If we need to look at the addition of vectors, we have these two vectors in the same direction, A and B. Look at them. If we need to add them together, the vector A in bold fashion, we don't have an row over A or B. If we need to add A plus B, we need just to take A and drag B and put the start point of B at the end of A, head to tail, and then we can add them together, and the resultant vector is the orange one, which is, we can name it C, for example. So this is A plus B, which is equal also to B plus A if we put B at the beginning and A at the end. This is the addition of two vectors in one direction. What if we have different directions for these vectors? This is A and this is B. We need to add them together. At first we need to take A, this is A. Then we need to take B and put its tail at the head of A. This is B. And this is the resultant vector, which is equal to B plus A. Look at here. We have, this is B at first. Then we put the vector A. And this is the resultant vector, which is the same direction and the same length. If we have two vectors with the same direction and the same length, then we can say that they are equal to each other. By seeing that A plus B is equal to B plus A, we can know that the vector addition achieves the exchange property. The drawing method. This is drawing method for addition of the vectors. We put the second vector at and we pull the second vector and we start at the end of the first one, which is tail to head. In this way, look, in vectors, the addition process, it is not simple. This is A plus B, and this is A plus B. We have the same vectors, A and B, the same length for A, but we have different direction. The same vector B with the same direction. But we have different magnitude because there is an angle between A and B. The change in angle between vectors will change the magnitude of the resultant vector. That is why I talked before and I told you the addition process is not simple as the scalars. The subtraction of vectors. If we have the vectors A and B again, if we have this A and this is B, and I need to find A minus B. It is easy. We know from before that minus B is equal to B in length but in opposite direction. Okay, A minus B. I can use this minus sign and put it for B. So I can add A plus minus B. This is B, this is minus B. Just I exchange the direction. Okay, I know how to add two vectors. I use the first one, which is A, this is A, and then add minus B to it. this is minus b. This is a, this is minus b, and this is the resultant vector, which is a minus b, or a plus minus b. We'll try that in the class. Let us try now b minus a. It's easy. We can use the minus sign for a. It will be minus a. Then we have the plus sign. So b plus minus a. I will use b at first, which is the blue vector. Then I use minus a, which is the reddish vector. And the resultant vector is b minus a. It is the same length as a minus b, but it is in the opposite direction. So you need to note that the vector subtraction does not achieve the exchange property. And the method of the subtraction is by drawing. We pull the negative of the second vector and place it at the beginning, and place its beginning at the end of the first one. You can use the fit simulation site to play with vectors and add them together. Okay, we have vector product. We will face this operation in the future many times, but I will talk briefly on it about it now. We have more than 3 ways to predict for vector product. This one is the cross product, which is a cross b. The resultant vector, if this is a and this is b, the resultant vector is this one, is a vector also, and this vector is perpendicular on b and a. If we have the red vector and the green vector, the cross product between them is the blue vector. It is perpendicular to their surface. If we need to know what is the magnitude of this new vector, it is the length of A multiplied by the length of B multiplied by the sine theta between them. If theta is 0, look here, when the theta between the green one and the red one is 0, the angle between them is 0, then the blue vector will be equal to 0. Also, we have the dot product. If we have A dot B, the resultant is a scalar. It is not a vector. And it will be the magnitude of A multiplied the magnitude of B multiplied by cosine theta. We will face this process later when we work with work, which is the force multiplied by the displacement. We have also the scalar multiplication. If we multiply 4 by the vector A, it is just A 4 times. If we have this is a vector A, 4A, it is the same vector A but 4 times. So we have a new vector with the same direction but 4 times length. It is easy. If you walk 1 step or 4 steps in the same direction, it is a scalar product with a vector. Okay, let us now deal with these vectors. Sorry, if we have this bird, for example, need to move from the tree 1 to tree 2. It can go directly using this way. This is a vector. We can name this vector any name you want. We can name it as V, for example. You are free. And it can go in different ways. For example, can go using the vector A, which is in bold. We can use also A with an arrow over it. And it can go using the direction for vector B, which is the blue one. I'll make it in this direction. Okay. And the third step, it can go this way with vector C. We can add more than one vector to give us a resultant vector. We have a position vector, for example. A position vector in general named by R. So the tree number 2 is positioned with vector R with respect to tree number 1. We have velocity V. If we divide the distance over the time, it will give us the velocity. We have the acceleration vector. We have the force vector. If we add two equal vectors together, look at here, please. We have this vector and this. If we change the direction, I just change the direction of that vector. So if I have this vector A and this is vector B, if I add A plus B, the result is 0. Okay, in this case, if we have if I make this process A plus B, it will be equal to 0. This will give me a result that A is equal to minus B in vector notation. Okay. Now, there are important relations. We need to focus on them. I think they are explained well in the block which is in the Canvas mathematical part. We need to know how to use the Pythagorean theorem. We have two sides for this right triangle. The side, the hypotenuse, I don't know, the adjacent, the opposite, okay. You know that h squared is equal to g squared plus f squared. And you need to know how to find sine theta and cosine theta and tan theta. For example, sine theta is opposite over the hypotenuse, and cosine theta is the adjacent over this, and the tan theta is this over this. We will use these relations many times in the future, and I think you will be fine with them. Thank you. Hi students, now we'll talk about components of vectors, which is section 1.8, and this section is in page number 14 in the book. In general, we will see different vectors and different lengths and different directions. For example, this is vector C with length 12 unit, and its direction is 60 degrees below the horizontal. This is the vector F, and its length is 20 units. Maybe it's in meters, kilometers, or it's speed or velocity units or force units, and its direction is 30 degrees below the negative or the left horizontal line. This vector direct 30 degrees above the right horizontal line, this, and so on. Horizontal line, left horizontal lines, vertical line, all of this can be embedded in the XY plane. As we see here, this is the vector B. Its length is 15 meters, and its direction is 30 degrees to the right of the y-axis. Vector D with length, and the direction of it is 53 degrees to the left of y-axis, and so on for each vector. This vector A with its length 8 and its direction downward or negative y direction. This is negative y direction. This is negative x direction. Also, there are different names for the axis. This direction we can call it east also. East. Also right. This is west or left. This is upward or north. This is south also, okay, or downward. Sometimes we can say that the vector B is northeast, but what is the direction in degrees? We need to know the direction in degrees. For right triangle, if we have a vector, and the vector in general will draw for us in the XY plane a right triangle. This is the vector A. This is the vertical component. We can name it AY. This is the horizontal component. We can name it AX. A in the direction of X. The component, if we have a vector like this and we drop a stone from it, it will reach the X component. And if we drop a stone on the y-axis, it will reach the y component of that vector. For a right triangle, we know the relations sine, cosine, and also tan. Theta. Where is theta? This is theta. Theta about one of the x or y axis. In this drawing, you can see that theta from the y axis. You can see theta from the negative x axis. For A, its theta with negative y axis is 0. Now we can call this angle is theta. In general, we use the positive x axis and measure the angle from the positive x axis counterclockwise. So sine theta, as known, is AY over A, and cosine theta is AX over A. I mean by A here, this is the vector A, but I mean the length of A. If we need to talk about the length or the magnitude of A, we put it between two vertical lines. So B is a vector. Its length is 15. So B magnitude is 15. Here, A magnitude between two lines is 8. From these relations, sine theta is equal to the opposite over the vector length. Then we can find sine and cosine relations, and we can find the ax and ay components, the xy components for the vector, which is equal to, if we take, for example, sine theta is equal to ay over the length of A. This is over 1. We can use this process. Then ay is equal to, multiplied by 1, is equal to the length of A multiplied by sine theta. And we have the ax component, which is equal to A, the magnitude of A multiplied by cosine theta. Ay component is the magnitude of A multiplied by sine theta. And by the way, tan theta is equal to ay over ax. And the Pythagorean theorem, which is ax squared plus ay squared is equal to the length of A squared. Okay, now let us look at this example here. If we have a vector r, the length of r is equal to, by using the Pythagorean theorem, as we see here, rx squared plus ry squared, but all under the square root of them. If we suppose that, for example, ry is equal to 5, rx is equal to 7, and we need to find the length of this vector. The length of this vector is equal to the root of 5 squared plus 7 squared, which is equal to 25 plus 49, which is equal to the root of 74, which is equal to 8.602 and something. We can round these values. After the 0, we can take it 8.6. Can we find the theta? Yes, we can. We can use the trigonometry relations. We can use tan theta, which is equal to opposite over the adjacent, which is ry over rx. Okay, ry is 5, rx is 7. Tan theta is equal to 5 over 7, which is equal to 0.71428 and so on. We can also round it. Theta, we can use the inverse function from the calculator, which is sine inverse, cosine inverse, tan inverse. We are dealing now with tan. If we need to find the theta in degrees, you need to be careful. You may work with radians or with degrees. Now I'm working with degrees. So tan inverse to 5 over 7. This is the angle, 35.53 and so on. This is the angle in degrees, not in radians. Okay, this is the way how to find the theta angle. We will solve more examples to make it more easy. Look at this example now. We need to find the components of each vector, given vector. If we have the vector f, denoted for the force, and we measure the force by Newton. We will come to it in its time. If we have the length or the magnitude of the vector force is 316 newtons, and the angle from the positive x-axis or from east is 35 degrees. We need to find the components. The components are the xy components. Fx, as we know from before, is f cosine, the length of f or the magnitude of f cosine theta. Fy is f sine theta. This is fx, and this is fy, which is the same length like this one. Okay. From the direction of the angle, always we will use cosine. Okay. So if x, that magnitude of f is 316, cosine 35 degrees. We need to be sure that our calculator on degrees. We will use radians later. So fx now is 258.85 newtons, and fy, which is 316 multiplied by sine theta, sine 35, which is equal to 181.25 newtons. Now we find fx and we find fy. I need you to note that in vectors, if you add two vectors together, the resultant value, it is not as the scalars. Add them together. Note that fx plus fy is not equal to the magnitude of f. If you add them together, it will be 440.1. It is not equal to 316 because there is an angle between them. They are not in the same direction. If they are in the same direction, then the resultant value will be the same. For example, if we have this vector is 3 meters and we have another vector 5 meters in the same direction, this is A, this is B, then A plus B is equal to 8 meters in the same direction. We need to put the direction which is in positive x direction. Let us now look at this example also. Now we take the angle from the negative x-axis. We need to find the components. This is ax, this is the vector A, which is 8 in length. This is ax. Now the component of x, the x component is on the negative x-axis, not on the positive. And the angle from the negative is 30. And we need to know also ay, which is the same this magnitude. We can use this. Ax is a cosine theta, which is 8, the length of a or the magnitude of a in meters, cosine 30, which is equal to negative 6.9 meters. It is in negative direction. The negative sign in physics means that the direction is in the opposite direction from the positive direction. Okay. Also, ay is equal to a sine theta, a sine 30, which is equal to plus 4. It is in positive direction, not in negative direction. What if we need to use the angle from positive x-axis? We know that this angle, total angle, is 180. So this rest angle is 150. Plus 30, it is 180. What if I need you to use 150? It's easy. Ax is equal to 8 cosine 100 50. It will give me the same magnitude, the same value, which is negative 6.9. Okay, because the cosine of any angle bigger than 90, it will be in negative. Also, AY is equal to 8 sine 150, it will be plus 4 meters. What if you come and ask me, what if my angle is about is from the y-axis? I will solve it now. This is y, this is x, negative sign, and this is our vector A equal to 8 in length, and this is angle 30. What is this angle? This is 90, so this is 60. Okay, I need to find AY, and this is AX. Now I need to use the angle 60. I don't need to use the angles from the X component. Look, we know from before that AY is equal to the length of A sine theta, and AX is equal to A cosine theta. That is in the case that theta from X, taken from X, this is theta. But if theta is taken from Y, then we need to use cosine with Y, not sine. So cosine theta is used to the with the component that we take the angle from it. So in this case, in this example, we will use sine theta, because theta from y-axis, and here we'll use cosine theta. Again, you will see now, this is 60. This is AY is equal to A sine cosine 60, and this is AX, which is equal to A sine 60. This will be equal to A, which is 8, cosine 60 in degrees. Look here, cosine 60, it is half. Sine 30, it is half. When we take sine 30, it is half. Also, when we take cosine 60, which is the rest to 90 degrees, it is the same value. So it will be equal to 8 multiplied by half. It will be equal to 4. Okay. Sine 60 and cosine 30 are equal also. So this will be equal to 8 multiplied by 0.866, which is equal to, as we see from before, 6.9, but in negative x-axis. Okay, in negative x-axis. The third page here, we have 3 vectors A, B, C. You have the magnitude of each vector in meters, and you have the angles about positive x-axis, positive y-axis, negative x-axis, you need to try to solve and find the components for each of them. You need to find ax and ay. You need to find also bx, by, cx, cy. We will try to do that together in the class. Thank you. Hi students, now we will talk about vector components and how to use these components in some computations. Let us take this example. If we have a vector v and a vector u, the vector v is starting from point 0, 0 and ends at this point S, which is 3 in x direction and 4 in y direction. So this vector has component 3 in x direction and 4 in y direction, and it's beginning from 0, 0. Okay. Also, vector u starts from G, ends with H. G is at -2 in x direction and 2 in y direction, but its end point at -4 in x direction and 4 in y direction. Okay, now we need to know the x component and the y component of each vector. We don't know how much the length of the vector v, and we don't know the angle theta for v. Okay, we don't know also the angle for the vector u. Let us start with vector v. Okay, vx, the component of vector v in x direction. We need to take the last or the end position in x direction, which is 3. The initial position, which is 0. The difference between them is 3 minus 0, which is 3 units. Maybe it is length, maybe it is force, maybe it is velocity, acceleration, or anything. It is just unit for this vector. What is the, so now the x component is 3 minus x, which is the x length for this for the x component for the vector v. What about the y component? It is 4 minus 0. So the length of the y component for vector v is 4 minus 0, which is 4. Okay, what about the vector u? For the x component for vector u, initial point is G, final point or end point is H. So the length of x component for vector u is the end point minus the initial point in x direction, which is -4 minus -2. -4 minus -2. This length, because it is in the x minus direction, it will be in negative sign. -4 to -2. We will keep the minus sign here. What about the length of the y component for vector u? It is 4 minus 2. It is also 2. Now look at these squares. H square is a half unit. 2 of them is 1 unit, 2 units, 3 units, and also here it is 1 unit, 2 units in negative x direction and 2 units in positive y direction. Now if we need to write the vector x and the vector y, we need just to write it like this, in this way. V as a vector is equal to v in x direction, which is Vx component and plus Vy, which is in y direction. We will learn how to write them later, but I need you now to know that the vector v, for example, is a 3 units in x direction and 4 units in positive y direction. But the vector u is ux in x direction and plus uy in y direction. Ux, we find it is -2 in x direction plus 2 in y direction. Okay? We can drag any one of these vectors, but we need to keep its direction and its length. It's easy to, for example, to draw the vector u in from here to here, since it has its angle, its direction theta u, and length. It is 2 units in negative x direction and 2 units in positive y direction. What if we need to add them together? It is easy. We need just to drag the vector u and put it at the end of, this is u. So this is the addition process, vector u plus vector v. It is okay to use any one of them at the beginning, so it is the same to say u plus v is equal to v plus u, as we see in the previous slides. We will change the scale. It is easy to change the scale, but just we need to keep the length of the vector and the direction. We can keep them by keep the components the same length. For example, as we see here, Vx is 3 units, Vy is 4 units. Okay, look at this vector. It is 1, 2, 3. This is Vx. 1, 2, 3, 4. It is Vy. So this is the vector V. This is also the vector U, because it is negative 2 units in x direction and positive 2 units in y direction. This is U. It is the same. Just I change the scale. We can do it. And I suppose, and I named the resultant vector, if I add them together, I name it as S. So S is equal to V plus U. If you see here, S is 1 unit in x direction and 6 units in y direction. So S is equal to 1 unit in x direction plus 6 units in y direction. Okay. Now we have the two vectors. V is 3 units in x direction plus 4 units in y direction, and U is -2 in x direction and +2 in y direction. This is the vectors again. Keep this graph in your mind. And from the graph, we found that S is equal to 1 in x direction plus 6 in y direction. It is easy to find that because S is equal to V plus U. And S contains two, or composed from 2 components, which is Sx and plus Sy. V is equal Vx plus Vy. U is equal Vux plus Uy. We need just to do this process. Sx is equal to Vx plus Ux. Also, if we have any other vectors, it is easy to do it. So Sx is equal to Vx plus Ux. Sy is equal to Vy plus Uy. So as we see here, Sx 3, Ux minus 2, it will be 1. Sy, as we see here, Sy plus Uy, which is 6 units. Okay, this is the vector S. What if we need to multiply one of these vectors by a number? What if we need to find 5v minus 3u? We see from before that we can multiply a vector by a scalar, by a number. This will give us the same vector but with different length. So 5v is equal to 5 multiplied by Vx plus Vy minus 3u. 3, the minus is minus, 3 multiplied by the vector u, which is Ux plus Uy. Do it here. 5 will go inside these parentheses and brackets, and this 3 also. Vx is 3, as we know from before. Vy is 4. We just need to multiply 5 by 3 plus 5 multiplied by 4 minus, which is the same minus, this minus the same, 3 multiplied by Ux, which is minus 2 in x direction, plus 3 multiplied by 2 in y direction. So we have 15 in x direction plus 20 in y direction, minus, with this minus will be positive sign, 6 in x direction, minus with positive it will be negative sign, minus 6 in y direction. So we need just to add the x component together, which is 21, and the y components together, which is 14. So this vector, new vector, we multiplied 5v minus 3u is equal to 21 in x direction plus 14 in y direction. Okay, now what if I need to deal with the vector v? This is the vector v. I need to find the length and I need to find the angle. It is easy. The vector v here is equal to 3 in x direction plus 4 in y direction. So Vx is 3, Vy is 4. If I need to find this vector v, I need to find its length. I have the x component 3, the y component is 4. I have right triangle. I can use the Pythagorean theorem. V, the length of v, is equal to Vx squared plus Vy squared. Vx 3 squared plus 4 squared, it is 9 plus 16. It will be the length, it will be the root of 25, which is 5 units. What if I need to find the angle theta? If I find theta u v, then I can find the direction of v. Again, this direction is x positive or east. This is y or north. I can't say in physics just the vector v is north east. I need to say the angle to be more accurate. Okay, I know that tan theta, this is theta, is equal to Vy, this is Vy, this is Vx, this is theta. This is the length of v. I know that tan theta is equal to Vy over Vx. Sine theta is equal to Vy over V. Cosine theta is Vx over V. I know the lengths. This is 3, 4, and 5. So I can find any one of them. Tan theta is equal to 4 over 3, which is 0.75. Cosine theta is equal to 3 over 5. Sine theta is 4 over 5. What is theta? It's the arc tan, or the arc cosine, or the arc sine, which is tan inverse or cosine inverse or sine inverse for this argument. So theta is tan inverse for 4 over 3, which is 53.13 degree. If I use the cosine, it is the same angle. If I use the sine, it is the same angle. But the fastest way is just to use tan, because I have Vx and Vy. I don't need to find the length of V. Before I find the length of V, I can find the angle for this direction, for this vector. The same way you can do it for the vector u. You can find its length and its direction by using the arctan or tan inverse, and the same for the vector s. You can do it. The length of u is 2.3883, and the length of s is almost 6. Okay, and you can find the direction of each one of them. We have here 2 examples. I will not solve them now. You need to try them. I will try them with you in the class. We have the vector A and the vector B. We have the components of each one of them, and we have the vector R. Just I need to find the length of R and the direction, which is theta, and the components of R. By the way, you can find also the length of A and B for these 2 examples. Also, we can use this example. We can do it also. We have vector A, B, C, and D. All together, they give me the resultant vector, which is R. So R is equal to A plus B plus C plus D. You need to know that Rx is equal to the x component for each vector, and the y component of R is equal to y component for each vector. You need just to fill this table and the length of, and also after that you can use also the Pythagorean theorem to find the length of R and the direction of R. Try that by yourself, it will be easy. Thank you. Hi students, now I will talk about section 1.9 unit vectors. Let us look at the vectors in the previous section, the vector v and the vector u. If we need to take a common quantity between the 2 vectors, which was the x direction and the y direction. If we look now to the vector v, the length or the components of vector v is 3 units in x direction and 4 units in y direction. If you remember, we wrote it like this: 3 in x plus 4 in y. Also the vector u, we write it minus 2 in x and plus 2 in y direction. We will not use this notation to write these vectors or any other vectors. We will use another notation, which is the notation for a unit vector in Cartesian coordinates, which is in x direction we will put I hat. We will use the hat to denote to a unit vector. The unit vector is a vector with length just 1. Okay, and these vectors even in x direction or in y direction, if we add them together they will give us any vector we need as a superposition of these vectors. For example, vector v again is 3 units or 3 unit vectors in x direction, 3 I hat, 3 in x direction, plus 4 in j hat. For in this notation, the x direction we will take I hat to denote for the x direction unit vector. For the y direction we will use j hat. We will use this hat. For a vector v we will use an arrow to denote for a vector. This hat is a vector, but it is a special vector which has a length just 1 and it direct to x direction with no angle about the x direction. It is with x direction and the angle with x direction is 0. This j hat, the angle of j hat with y direction is 0. Also we have in our life 3 dimensions: x, y, and z or z. So we will use also in z direction we will use k hat. So we have 3 unit vectors I, j, and k. It will be easy to use them. We will see that in the examples. Okay, now what about the vector u? Again, u is minus 2 in x direction, minus 2 I hat plus 2 j hat. There is no component in k hat. We can put it 0 k hat. We don't have any third dimension here. Look at I hat. I hat is always direct to the positive x-axis. This is I hat. But in the vector u, it goes in the negative direction, in x direction. So we will use the same I hat, but with negative argument. Minus 1, minus 1, it is minus 2 in this direction. This direction is 2 with minus sign in I hat direction or in x direction, and plus 2 j hat. What about s, which is the summation between u and v? It is 1 unit in I hat in x direction, 1 I hat plus 6 j hat. It's easy. Let us look at this example. What about the vector a? A again it is ax I hat plus ay j hat. Ay, it is the component of the vector a in y direction, but where is its direction? It is in the direction of j hat or in y direction. As we see from the graph here, ax is 11.3 in I hat direction and ay is 4.1 j hat. The same for b and the same for r. You can add the x component for a and b to find r in I hat direction, and the y component for a and b to find the y component for r in j direction. And also you can count these lengths with the right scale. What about this example again? We have 1, 2, 3, 4, 5 vectors R, A, B, C, D. Again, we need to write them in I and J hat notation. It is easy. Now, what is the, for the vector C? What is the X component for the vector C? It is, be careful that each unit is 1 unit in this scale. So the length of C is 1, 2, 3, 4. In it is, but in negative sign, it is -4. What about the Y direction? For the vector C, it is 2. 1, 2. The vector, it is -4 I hat plus 2 J hat. The direction, I need you to find the direction theta, which is tan inverse to Y component over X component, 2 over -4 in degrees or in degrees, okay? What about the length? The length, using the Pythagorean theorem, is the X component squared -4 plus 2. But I need to square them. Be careful. If you put just 2 as a power, 2 squared is okay. But if you put -4 squared in this way, sometimes we will, maybe me also, make a mistake and make it, because 4 squared is equal to 16, and you will keep the minus sign, it will be -16. That is wrong. We need to put -4, all of it, to the power 2. We need to square all the value, okay? This is, you can do this for all the vectors, and you can fill this table again. Let us now look at the vectors in 3 dimensions. Now we have the vector, we have the Cartesian coordinates X, Y, and Z. If we have a vector A, which is AX, AY, and AZ, but AX will be in I direction, I hat, J hat, K hat. AX in I hat, J hat, K hat. This is the vector. And the length, using the general form of the Pythagorean theorem, or the Pythagorean theorem in 3 dimensions, which is AX squared, AY squared, AZ squared, all under the root. For this example, we have the vector P is written as 3, 0, 5. This is equal to 3 I hat plus 0 J hat plus 5 K hat. These are the components. The vector Q, it is -5, -3, and 7, which is equal to -5 I hat minus 3 J hat plus 7 K hat. If we need to draw this vector from the origin, which is 0, 0, 0, this is the vector. This vector is the, look at the Y component, it is 0. The vector P, it lies in XZ plane. Okay, it will not be that difficult. Okay, in general, we will not use these vectors in our study, we need just to be careful to deal with the vectors in two dimensions. Thank you. Okay students, now we'll talk about important operation for vectors, which is product of vectors. We have two kinds of for product of vectors. First one is scalar product or dot product or inner product. All are the same. And the second one is vector product or cross product. The notation of the cross product is A cross B, and the resultant is a vector, another vector. We will see its properties later. Now we will talk about scalar products. The scalar product A dot B or dot product A dot B, it is a scalar, it is just a number, which is C, it is not a vector. We have two methods to find the dot or the scalar product. The first one, if we need to find A dot B, if we have the vector A, we know its length. We have the vector B, also we know its length. We have the theta between them, between A and B. The dot product is the length of A multiplied by the length of B multiplied by cosine theta between them. Theta is taken from the first vector to the second vector counterclockwise. The length of A is, using Pythagorean theorem, is ax squared plus ay squared plus, if we have, az squared. Also the same for B. And the component of, or the projection of B on A is the scalar product quantity or length or something like that. The second method, if we have the components of each vector in I hat, j hat, and also k hat, if we need, we don't have the length of each of them, we don't have the theta between them. The scalar product is the product, the direct product between each component, ax bx plus ay by plus az bz. This is the scalar product, the second method. We can use any one of them that depend on the question. Let us look now at the examples. We have the first example using the first method. If we have three vectors A, B, and C, and the angle between B and A is theta AB, the angle between B and C is theta BC. I need you to find A dot B, A dot C, B dot C, B dot A. It is not A dot B. It will be the same. If we have the length of A is 5 meters, for example, the length of B is 3, the length of C is 1, and theta between A and B is 30 degrees, and theta between B and C is 100 degrees. Okay? Okay, it's easy. A dot B is equal to the length of A multiplied by the length of B multiplied by cosine theta. The length of A is 5, this is 3 cosine 30. It is easy using, you can use the calculator. 5 multiplied by 3 multiplied by cosine 30, which is equal to 12.99. It is almost 13. Where is it? It is almost 13. Okay? And if the unit of A is meter and the unit of B is meter and cosine is unitless, then the unit here is meter squared. Okay? This is a way to find the area. Okay, what about A dot C? Which is the length of A multiplied by the length of C which are known, and cosine AC, theta AC. We don't know theta AC. We don't know the angle between A and C, but we know this angle between A and B and the angle between B and C. We can add them together. Theta AC is equal to theta AB plus theta BC. 30 plus 100, it is 130 degrees. It will be, again, we can find it, 5 multiplied by 1 multiplied by cosine 130. The total angle between A and C. 5 multiplied by 1 multiplied by cosine 130. It will be negative 3.2139 and so on meter squared. The negative sign direct or give us a hint that the total area is in negative direction. We will talk about that later, but if you look here at C and A, they are in opposite direction, in X direction. Okay, also the same for B dot C. You can find theta is known, it's 100 degrees, B length is 3, C is 1 in length. Now this is important to be known. Okay, B dot A, we found A dot B. A dot B is A length, B length, cosine theta AB, but now B dot A is B length multiplied by A length, cosine theta BA, not AB. Okay, this is A, this is B. This is theta between A and B, counterclockwise from the first vector, which is A in the first example. But now the first vector is B. Counterclockwise from B to A, we have the total angle, which is 360 negative 30. This is 30 degrees. This angle is 330. Total together, it will be the total angle, which is the total rotation, which is 360. So we can find this angle, and by that we find angle, the angle between B and A, not between A and B. It is 330, cosine 330. But be careful that, or you will find that cosine 30 is the same as cosine 330. It is the same, which is 0.866. By the way, cosine and sine must be less than 1 always. Okay, so cosine 330 is equal to cosine 30. In this way it will be the same answer as the first one, because we have 5 multiplied by 3 is the same, 3 multiplied by 5, which is 15, multiplied by cosine theta, which is the same here. And the question, the answer will be almost 13 meters squared. Okay, so it's the same, because cosine theta is equal to cosine 360 minus that theta. Okay, now let us look at this example using both of methods without using any graphs. If we have the vector A with its components, also using the third dimension, A is equal to 5 I hat 6j hat minus 3k hat, B is equal to negative 2 I hat plus j hat plus 7k hat. I need you to find the angle between these two vectors. We have this vector and this vector. They are in the 3-dimension coordinates. I need to find the vector, the angle between them. This is the angle. Okay, how to do that? Using the scalar product, we can find the angle. We have two methods. A dot B is equal to the length of A multiplied by the length of B cosine theta AB. which is equal also ax bx plus ay by plus az bz. The two quantities are the same, they are equal because they are a dot b. So we can equalize them. A length, B length, cosine theta AB is equal to ax bx, ay az bz. Just we need to divide over the length of the vectors, both sides. So cosine theta will be equal to ax bx, ay by, az bz over the length of A multiplied by the length of B. We can forget the arrow here because we've put the length. Okay, this is the way how to find the angle theta. It is easy to find the length of A and the length of B using the Pythagorean theorem. Ax squared, ay squared, b is az squared under the root. Be careful, we have minus signs, so we need to use the parentheses. So the length of A is 8.366 units. Sorry, and the length of B in the same way, it's 7.348 and so on units. Now we find the lengths. It's easy also to find the dot product using the components. Look here, a dot b is equal ax bx, we have them, ax bx 5 multiplied by minus 2, ay by 6 multiplied by 1, multiply here the component is 1, az multiplied by bz, which is negative 3 multiplied by 7. We can find that is negative 25 unit squared. Okay, now we need to use this formula. It is easy. Cosine theta AB is equal to the scalar product using the components over the lengths. The lengths are in units squared. Also here we have the same units squared, so we can cancel each other. So the cosine theta it will be unitless. Now the scalar product using the component is negative 25, and the lengths for A and B we found them 8 point and 7 point. The answer will be negative 0.406 and so on. Okay, cosine theta is less than 1 or minus 1 because cosine theta always less than positive 1 and bigger than negative 1, also sine. Okay, we need to find theta. It is the arc cosine or cosine inverse. It's the same representation. Okay, of this answer it will be 113.97, which is almost 114 degrees. It is the same approximately this angle between A vector and B vector. This is the first kind of vector product. See you in the next one. Thank you. Hi students, now we'll talk about the same section but cross vector product. If we have two vectors A and B and they lie in a plane, this plane as we see here, if we need to, and the angle between them is theta, if we need to find the cross product or the vector product between A and B, the resultant is a vector. This vector is perpendicular on A and perpendicular on B also. Okay, so if this paper is contains the vector A and B, then the third dimension or the third vector, which is a product for A and B, is perpendicular on both of them. Also, if we have these are two vectors, this one cross this one is perpendicular on both of them on the surface that contains these two vectors. And you need to know also the cross product for two vectors will give us the area of the shape between them, the quad this shape. And if we take A cross B, starting from A ending to B, the vector will be perpendicular upward, for example. But if we take B cross A, the vector will be downward, which is negative. A cross B, it is the same in length but with opposite direction. So we have C is equal to A cross B, and the magnitude of C is equal, or the length of C is equal to the length of A multiplied by the length of B multiplied by sine theta between the vectors. We talked about this relation before. In general, now we need to talk about vectors using the components I hat, j hat, and k hat. If we had a vector R, and this vector is I hat plus j hat and k hat, just one unit in each direction. If we need to now to find that dot or scalar product between R and R, the same vector, it will be I hat plus j hat plus k hat dot the same vector I hat, j hat, k hat. The way to do this, we take a shortcut for this way, which is I hat multiplied by x component multiplied by x component, y component by y component, z component by z component. But in general, if we need to take the product for all the components, then we find that we need to multiply I by I, then I by j, then I by k, I hat plus I hat j hat plus I hat k hat, then j multiplied by I plus j multiplied by j, then j multiplied by k plus k multiplied by I, k multiplied by j, k multiplied by k. In scalar or dot product, any two unit vectors not the same, the dot product between them is 0. So I dot j is equal to 0, I dot k is equal to 0, j dot I is equal to 0, j dot k is equal to 0, and the same for k dot j and k dot I, they are zeros. But I dot I, j dot j, k dot k is not zeros, it is 1. Okay, I dot I is 1, j dot j is 1, k dot k is 1. So the resultant value is 1 plus zeros plus 1 plus 1, which is 3. Okay, now you need to be sure that I dot I is equal I hat is equal to j hat dot j hat, which is equal also to k hat dot k hat, which is equal to 1. Any one of them. But if we add them together, 1 plus 1 plus 1 is 3. I tell you about that to be sure about your calculation in dot product. But if we go, it is simple in general. We don't need to do this process. We need just, in general, we need just to multiply x component by x component, y component by y component, z component by z component. but that is different in vector product. Now we need to use these basis vectors, the basis vectors or the unit vectors, which are I, j, and k. If we multiply any vector with itself, it will be 0. That we need also to use the permutation relation, this one. If we have x, y, and z in 3 dimensions, if we multiply x direction or I hat by j hat, it will give us z hat or k hat. If we multiply j hat by k hat, it will give us I hat. If we multiply k hat by I hat, it will give us j hat. But if we have the opposite direction, if we multiply j by I, it will give us minus k. If we multiply I by k, it will give us minus j. We can see here that I hat cross product, not dot product, I hat is equal to 0, j cross j is 0, k cross j, is 0, but I cross j is equal to plus k. They are in the same direction, clockwise. J cross k is I, k cross I is j. The opposite direction, j cross I is minus k, k cross j is negative I, and I cross k is negative j. We need to solve some examples. Okay, look at this example. If we have two vectors a and b, we need to find the scalar product and the vector product. We will do it in details, then later we will do them or any example in the simplest process. Okay, now at first let us find the length of A and the length of B. The length of A, or the magnitude of A, is the square root for the square of each component. 4 squared is 16, negative 2 squared is 4, negative 9 squared is 81. It will be the root of 101. And the same for B. The x component is 0, 36 is the square, and negative 1 squared is 1. This is the root of square root of 37. If we need to find the angle between them using the dot product relations, what we learned before, the dot product relation, if we multiply the x components, 4 multiplied by 0 is 0, negative 2 by 6, negative 12, negative 9 by negative 1 is 9. It will be negative 3. This is the process by details. Divided over the lengths, what we find 101 and 37 under the root. Then cosine theta between A and B is negative 5%. Okay. Then theta is the cosine inverse of this value, which is 92.81 degrees. Okay. If we need to find the dot product and scalar product, which is scalar product in details, as I explained here, it is a long way, but we have zeros. I dot j is 0, I dot k is 0, j dot I is 0, j dot k is 0, k dot j is 0, k dot I is 0. All of these are zeros. The rest of them, diagonal one, which is I dot I, j dot j, k dot k. 0, negative 2 multiplied by 6, which is negative 12, negative 9 by negative 1, which is 9, then the result is negative 3. What if we need to find the vector product or cross product? Okay, again, we have A cross B is equal to, this is the vector A and this is the vector B. The vector A, we need to multiply 4I cross 0I. 4 multiplied by 0, I cross I. 4 multiplied by 6, I cross j, I cross j. 4 multiplied by minus 1, 4 multiplied by minus 1, I cross k, I cross k. Negative 2, negative 2, negative 2, negative 2, negative 2 multiplied by 0, j cross I. Negative 2 multiplied by 6, j cross j. Negative 2 multiplied by minus 1, j multiplied by k. The same for the z component. K cross I, k cross j, k cross k with the numbers. Now, this 4 multiplied by 0 is 0. I cross I is 0, as we see in the definition. Any two equal directions are 0 in cross product. And j cross j is 0. K cross k is 0. Okay? So this is the diagonal, or the where I, j, j, k, k are zeros. 0, 0, 0. Okay, what about, we can find the numbers. 4 multiplied by 6 is 24. 4 multiplied by minus 1 is minus 1. Now let us see the cross product for the unit vectors or the basis vectors. I cross j, they are clockwise. Okay, I cross j is plus k. I cross j is plus k. I cross k. I cross k is negative j, because it is counterclockwise. J cross I counterclockwise, it is negative k. J cross k, the order is I, j, k. We need, in this direction is positive, in this direction is negative. J cross k, j cross k is, we can return to the beginning, is plus I. K cross I, k cross I, it is, k cross I, it is in the positive direction, because we can go return to this direction. Okay, it is plus j. K cross j, k cross j in opposite direction, it will be negative I. Now we have these in I direction. We add them together, we have negative. With negative it is positive 54, and positive 2 it is positive 47. I'm sorry, here we have a typo, it is 57. Yes, we will find it right. Okay, the j direction we have 0, we have negative with negative, it is positive 4, with 0 is positive 4 j, and we have 0k and 24k, it will be 24k. So the cross product is A cross B, which is equal to 57I plus 4J plus 24K. Okay, now we have these relations. If we need to find the A cross A dot B as a magnitude and A cross B as a magnitude, not as a vector. The difference between the dot product and cross product is this: A dot B is equal to A B length cosine theta, but A cross B magnitude is A magnitude of A multiplied by the magnitude of B sine. One of them is cosine, the other is sine. We know the angle, we found it, and the length of them, we found them. So A dot B is equal to -3 as we find here, and A cross B as a magnitude, the length of this vector, which is cross product, the resultant from the cross product between A and B is 61 unit. Okay, now let us look now at these vectors also. If we have the vector x and y and z with different lengths, what if we need to find a cross product? I don't need a dot product. Dot product x with y, it will be 0. I dot j is 0. Just one component for each vector. J dot k is 0. That means they are perpendicular on each other. The angle between each vector and the other is 90 degrees. Okay, you can find it using this relation or this process. You can find the angle between these vectors using this process. To find the angle is 90. But what if we need to find the cross or product? It's okay, I will do this one. X cross, this is cross y, it will be, this is cross, okay, it will be 4I cross I hat 6J hat. It will be equal, I will take the numbers together, 4 multiplied by 6 and I cross J as unit vectors. This will be equal to 24. I cross J, they are in the order I, J, K. In this order is positive, it will be K hat. Okay, this is the resultant vector. For this vector, you can do the any cross product between these vectors. Look at these vectors R and F. 5I plus 2J. 5I plus 2J. They are the same. They are two vectors, the same length, the same direction. What is the cross product between them? Okay, R cross F is equal to, I will multiply 5I by 5I, 25. I cross I is 0, so I don't need to do it. Okay, 5 multiplied by 5, I cross I plus 5 multiplied by 2, I cross J. I cross J plus 2 multiplied by 5, J cross I plus 2 multiplied by 2, J cross J. We have I cross I is 0 and this one J cross J is 0. Okay, this will be equal to 2, this is 10. I cross J is K. plus 10 to multiplied by 5. J cross I is minus K. I can take this negative sign outside, which is 10K hat minus 10K hat. It will be equal to 0. This result told us, or tell us, that any two vectors in the same direction, whatever the length of them, the cross product between them is 0. If I look to this relation, if they are parallel, I'm sorry, if they are parallel with this, the angle between them is 0, the angle is 0, sine 0 is 0, then the cross product between them is 0. Do it by yourself, use any two vectors and you can find the angle between them. We will try this by yourself and we will do it in the class inshallah. Assalamu alaikum.